Now I think it's high time we looked at some examples at least, sample examples of read and write system calls. Maybe what we can do is say, we want to read one byte. We can start off with saying, I want to read one byte. We'll have to start reading small quantities at a time and graduate results to bigger quantities. So first sample is to say read one byte. In which case what we require is we need to have process data space to hold that one byte. We need a 1 byte pocket anywhere on the body, correct? So we require that that could be in the stack segment, data segment, any place. It doesn't matter. So we require just 1 byte space here and give that address to read and say please transfer that into that place, right? That's what we need to do. So we say we have one char, let's say x. Yeah, char x is a declarative statement which could be a local or a parameter or a global or a static. It does not really matter because there you have the pocket. It's absolutely no problem. So it works on it as long as that is your legal process data space. So when you say, of course, read 1 byte, don't forget to check for the return value of the read. Now he can only read 1 byte or 0 bytes, right? He can't read anything more or anything less. Of course, read itself is likely to return a failure. Read has got failure also. Failure in read probably is that segmentation violation in which anyway we don't have any control. It kills the process. The other one is probably you say you n bytes you give a negative value or something. He might give you an e param which says that parameter fault. No, you give a negative. You say please read minus 10 bytes. Obviously, this is going to be some confusion with the read system call. So that could be a parameter fault. So error no will be e param, and of course this could be an FD fault also. You forgot to open the file or open was not successful at all, and you ask him to read. He says, "What is this, man? You asked me to read a book, but you have to give me the book first, no? There must be a proper book which is successfully opened before you say you can go ahead and read the first page and second page and third page and so on. So that could be a parameter fault. I'm not talking about those faults of read. Successful read can only return 0 if no more bytes are there. If the file position is just beyond the end of the file, now even 1 byte it will not be able to transfer, or if it is anywhere before that, it can successfully transfer 1 byte. So read is going to return either a 1 or a 0 or a minus 1 in the case of failures. Yeah, our interest, I think, is only to say if it is not equal to 1, we will say it is. Yeah, we are going to just read that saying if the read does not return a 1, we don't need to proceed with this program. There is nothing more we could do. So your interest is to check only that. It says, so for example, you say if read of, the open and all that are statements which are there before this. I'm not writing those. If read comma fd comma, you have to give the address of the only byte in the process data space, which is an ampersand x. And the number of bytes to be transferred is just 1 because everybody knows the size of 1 byte is 1. No, it's known stuff. So 1. If this is not equal to 1, we suddenly decide and say there is something wrong. I'm not able to read the 1 byte. That means most likely we have reached the end of this file itself. Of course, the read itself is not failure. But we suspect read is not going to fail in such a simple case. Ampersand x definitely is not an illegal data space. It is legal data space because char x we have declared right now. So obviously, compiler is not going to generate one funny address for this. It's going to be within our process data space. And FD, just before this, we have done an open and made sure that the FD was all right, was not less than 0 or was not equal to minus 1. We just verified FD is all right. This address is all right. Byte count, we can see it is all right. So the only possible returns from this particular read, I expect most of the time, is 0 if there are no more bytes to be transferred, or 1 if that byte has been successfully transferred. So in which case, you just have to check for 1 and say not equal to 1. You might want to give some message to the user or whatever. This is part of the application. I'll just indicate that this is not exactly the statement that you may want to execute. It only indicates the kind of action that you want to take depending on the kind of application that you are developing. So fprintf stdr, end of file, or reached end of file or whatever, or no more bytes to be transferred, whatever the kind of message, and then of course exit from the process. But this, even though you printed error message, this is not an exit 1 or exit 2. It is a successful exit. I finished reading the entire book. Just because there is no more pages to be read from the book doesn't mean that I have failed in reading it. So I have successfully read it. So it's an exit 0. Now let us look at a slightly more complicated example of saying I want to read an integer. See, integer is interesting in the sense that the size of the integer itself could be different for different systems. Different compilers really, different implementations of compilers. So, what you have to do, you have to be careful there. So maybe we have one int y semicolon is a convenient way of asking the tiler to stitch the appropriate pocket. Correct? You should never show a small pocket and say buy one coconut and put into the pocket. That is what happened. We generate in segmentation violation and enemy is going to kill the process. So int y is a very convenient way of getting one pocket, standard size. And then say if, for example, we say if read of fd, comma. Now ampersand y is what we want to say because we want to give the address of the first byte to be transferred. But unfortunately, when you say ampersand y, what you get is not address of a byte, you get an address of an integer. What you get is an ampersand int or int star is what you get. But address of an integer is nothing but, physically speaking, is the same as the address of the first byte of that integer. Right? So why don't we cast that address itself as an address of the first byte by doing a cast operator, char star, and say ampersand y. So that is what is there. So that is the address that you have to specify. So address of the first byte of that n byte number of integer, 2 byte or 4 byte integer is what you have to pass as parameter. Because as far as read and write system calls are concerned, is always reading bytes. What you want to use it for a byte, for a char, or for an int, or for a double, or struct emp, or whatever is up to the process. So read does not care less. Okay. So that is what it is. And the number of bytes will be transferred again. Don't say comma 2 or comma 4, because that is implementation specific. We want our program to execute conveniently and correctly on all the systems. You just have to take it there, recompile it, it should work. We want to write a portable program, you have to say size of int. That's a convenient way of saying that, because size of is an operator, can always produce the size of the integer, which is the implemented value in that specific compiler. So close bracket. Of course, for the read, now this is going to definitely return either a 0 or less than size of int. If it returns 0, obviously there's nothing left. Or 1, 2, 3 also is not sufficient. 4, if the size of int is 4, if this is not equal to size of int. Anything less than the size of int, it can never be more than size of int, correct? So when you ask him to buy 1 packet of cigarettes, he cannot buy 2 packets. He is prohibited from doing that, but he could buy half packet. But in this case, we are saying, let's say I read 2 bytes of an integer, there is no point in proceeding. You don't have the full integer, correct? Only the first 2 bytes have been filled up. Rest 2 bytes, whatever the old contents were there. So what you have now as the int value of y is totally junk, correct? Whose complement value is junk. So you may not want to proceed and say, so now print appropriate message and exit. So, or whatever action that you want to take. That's how you would want to read an integer. And supposing you want to read a structure. The same, practically I would suspect it's practically the same like what you have got here. You say I got a structure itself as then you have to take the address of the structure, address of the first byte of the first member of that structure, pass that as a char star, and pass the size of the structure as the number of bytes to be transferred, confirm that the return value is equal to the size of the structure, and then you say successful or failure. Right? There is no difference, except that in the case of structures, what I suspect is reading structures is almost like the record handling of the COBOL. So you say I want to keep on reading. Employee file has got employee struct emp array of these structures. In case it reads anything less than the size of the structure, that means it's not just indicating the end of the program, it indicates there is a corruption in the file, data file. Because it's saying, when you say I got an employee master file, must be a multiple of that structure size, correct? Otherwise, you got the last employee has been cut, half the information. So there is something seriously wrong with that data file itself. So you may have to give a more serious message here if you find a structure cannot be read completely. A partial transfer of a structure definitely is much more important. It's like saying, buy 1 pen and come back. And he says, no, I could get only the cap or something. Or this. Both you can't use. Even this is useless. Correct? When it's a structure is there, all the members of the structure must be there. Otherwise, you can't use this structure itself. So obviously, there's something wrong with the shop. So don't buy pens from that shop again. Right? So there is a corruption of data file is the conclusion that one has to come to. So that is on the read and write system calls. Why don't we just quickly look at a couple of other system calls that we have here. 10 minutes we can spend on that. Yes, please. Then you can always say n bytes is different. The last parameter you can say I can read 1 byte once, 10 bytes next time, 15 bytes third time and so on. Absolutely, we have no problem. No, then it will be different structures. No? What is variable length record? Occurs some n number of times, not depending on some other option. Correct? So, what is the kind of data type that you have for that in C? Yeah. So now the number of bytes you know how many to read, or there is the depending on option is there. I mean, talking with respect to the COBOL because you're asking me with respect to COBOL, correct? So we are saying that what he's saying is something straightforward. So you got a file, right? So he says I got 1 record, is no problem. Let's fix some size. Now you say I got 1 more record. In fact, record there is one small part of the record, one field. This is an integer, okay, which says what is actually the rest of the length of the record. It indicates that. Okay, you have to probably multiply that by a number. So you say this XX value is different, then you may have to read actually so many bytes. Next, again, it says this XX value is different. Maybe you have to read some less number of bytes and so on. So this is what is known as variable length record. C has absolutely no problem. You have to do actually multiple data transfers. First you do this transfer, find the value of XX, and then do this transfer. Again, this transfer, value of XX and the different size transfers. So you can always do that. C has absolutely no problem about variable length records because it does not have a concept of record at all. No? COBOL, it was a special case because COBOL was always transferring fixed size records. So they had to go for a special scheme for variable length records. Internally is a separate row of the file table. It's just a long number. File position is just a long number because we know the size of the file cannot be more than 4 gigabytes. Because the size of the file itself is one of the items in the inode information. If you recall, we just use one unsigned long for that, right? So therefore, you cannot have a file which is larger than 4 gigabytes in any case, right? It's just a long. So just a long number which is part of that row of the file table. And each open instantiation is a separate row. They could be progressing with different speeds. The multiple instantiations of the same path name. It's possible. Is in the file table row number. Is a bookmark. That is a bookmark. Is like saying we find one very interesting book magazine, which is your favorite magazine, whatever that is. Very interesting. They say, oh, both of us will start reading. Or 3 of us will start reading, no problem. Initially, all of us will start from page. Everybody wants to read from beginning to end only. We start from page number 1. I am a fast type of reader, so I go to page number 2, so I flip the page. But you say, wait a minute. So you stand like this and you are reading the first page, I am reading the second page and third page and so on. Then you come to the second page, I am probably on the fourth page. You come to third. See, that's the multiple instantiation. It's a bookmark. That is a file position. Long, just a long number. Once you say I got a long number, it is the 50,000th byte of a file. You know actually which logical data block it appears if you know the block size. And you know where is that data block because you got the data block list as part of the inode information. So file management system knows. See, it's the inner working. You are asking me, where does that shop fellow keep the 11th packet of cigarettes? I personally feel we should not worry about it. Let him keep it where he wants, as long as he gives us that 11th packet of cigarettes when we go and ask for it. Right? It's a transfer. Of course, we did discuss the internals of FMS, and I want to go back to the internals in the next session actually. We would like to see how the shop organizes the inodes and data blocks. I think there is some serious problem there. He's got some problems. So I would like to see his problems also. But today we are not addressing his problems, we are addressing our problems. We have a different perspective. We are looking at the same coin, but we look at different sides of the coin at different points of time. We are looking at it from this side now. Tomorrow we are going to come back and look at it from the other side and see what problems FMS has got when you keep on issuing millions of reads and writes. Some calls is another problem. FMS also is going to have problems. The shop fellow, some n number of fellows keep on coming and say, give me this cigarette, give me that, give me that, give me this pan beta or whatever, no? So he's got to physically take it and give it, physically take it and give it. Is he having some problem there? Can he be very fast or is he going to be slow? What are his problems? Each fellow has got his. You go and ask him. So in fact, how is life is one standard question that people ask. How is life? No? When you meet somebody and say, hi, how is life? I used to meet somebody in the Bangalore once and say, how is life? He says, terrible. No, I met him just 2 times. I said, terrible. Then 15 days later, he says, life is fantastic. I said, come on, 15 days, within 15 days, life cannot change so much, no? From terrible to fantastic. He says, no, UB beers are actually available now, no? That's why it is fantastic. I mean, he doesn't drink. He's got a beer shop. He's got a wine shop. Where one of the primary commodities is UB beer. United Breweries beer. And if that is not available, he is not doing business. For him, life is fine only when United Breweries is giving unlimited supply of beer. See, his point of view of life is that limited point of view, correct? So each person has got his view of life. And in fact, Unix also, you look at it from different points of view. Now I'm looking at it from the processes point of view. We can see that, we are the process today. Tomorrow I'm going to become file management system. And then you see, when you look up and see, hey, n number of these processes, everybody is trying to do multiple access. What am I going to do? Are we having problem? No problem. That is a separate perspective. I don't want to worry about that today.